Welcome back to the Deep Dive. Today we are taking on a topic that sits right at this intersection of, well, microscopic threats and life-saving procedures. We're talking about the meticulous manual cleaning of flexible endoscopes.
Hmm.
And when you think about an endoscope, all its valves, its channels, its optics, cleaning is a massive understatement.
Oh, completely.
So we've pulled our sources from these really dense technical manuals that professionals use. And our mission is just to peel back the layers on these non-negotiable steps. This is the manual phase, the part that comes before high-level disinfection or HLD.
And it's really the ultimate setup play. I mean, if we're talking about infection prevention, manual cleaning is the single most critical step.
Right.
And we have to be so clear on why. If you don't physically and meticulously remove the layers of biofilm and bioburden.
So that's the organic stuff, blood, tissue.
Exactly. If you don't remove that, the HLD chemicals, they just can't penetrate. They can't reach the organisms underneath that protective layer.
It's like trying to wash a really dirty shirt, but the water just beads up on the surface.
That's a perfect analogy. The underlying contamination just stays put.
Okay, so let's unpack this. It's a high-stakes choreography. And we're starting after a really crucial prerequisite, right?
Yes.
The scope has to pass a leak test first.
The leak test is the gatekeeper, has to pass. That test makes sure the scope's integrity isn't breached, because if water gets into the electronics, well, the scope is ruined.
So assuming it passes, we move to preparation.
We do.
And even the prep itself tells you how specific this all is. You start with the sink, you plug the drain, fill it with lukewarm water. I think the sources said usually between, 80 to 110 degrees Fahrenheit?
Yeah, around there. It depends on the manufacturer's instructions, the IFU. And that temperature range is critical.
Why is that?
Well, too cold and the detergent isn't as effective, but too hot, and you can actually risk coagulating proteins.
Oh, making them stick even more.
Exactly.
Yeah.
You'd be making the problem worse, basically defeating the entire purpose of cleaning.
But here's the detail I found fascinating.
Yeah.
The order of operations.
Hmm.
You have to fill the sink with water first, and then you add the detergent.
Yes, and that's purely for equipment protection. If you just dump the detergent in and blast the water on top, you get all this foam and aeration,
Doubles.
a rush of bubbles, and that could potentially damage the sensitive internal mechanisms of the scope.
Yeah.
It shows you how every single step is designed not just for cleaning, but for protecting this incredible expensive instrument.
So we've got our perfectly temp-controlled water, detergent mixed in, scope is cleared for cleaning.
And this brings us to what I'd call the first non-negotiable rule, the immersion mandate.
Okay.
The endoscope must be completely, and I mean completely, immersed in that solution for the entire process.
No part of it comes out of the water.
Not until you're totally finished with the manual clean. It ensures every single surface is constantly being treated.
Got it. Stay submerged.
Hmm.
So now we clean the exterior. We're using a sponge or a cloth dipped in the solution, and the technique is. It's really specific.
It's basic logic, but, rigorously applied. You start with the cleanest part of the scope.
Which would be the control section where the technician holds it.
Right. And you wipe down the length towards the dirtiest area, which is the insertion tube, the part that was inside the patient.
So you're always working from clean to dirty.
Right.
It's an active strategy to stop you from dragging contaminants back over an area you just cleaned.
Precisely. So once that's done, the exterior is clean, the scope is still fully immersed, and we move immediately to the internal access points, the valves.
And this is where we ditch the simple cloth and pick up some highly specialized tools.
Absolutely. The tools are as specific as the instrument itself. We have what I call the Goldilocks rule of brushing.
The brush has to be just right.
Just right. You have to use the correct manufacturer design brush for that specific scope. A brush that's too thick could damage the channel lining. One that's too thin will just miss the gunk. It won't create enough friction.
Wow. So the technician has to know the exact tool for every single model of scope they work on.
Every single one. And our sources list 4 areas to scrub with this brush: the suction valve, the air-water valve, the biopsy valve, and the suction connector.
And the technique is just as specific. You insert the brush, and you have to do a full 360-degree turn.
That rotation is essential. It ensures the bristles make contact with every millimeter of that opening, and then that brush is immediately discarded.
Single use.
Single use. It's contaminated, no question.
Okay, valves, done. Now for the internal channels, the long, flexible tubes. This has to be the hardest part, right?
Yeah.
This is where everything
This
hides.
is the heavy lifting, for sure. We're talking about microscopic highways here, and you need different brushes for this part. A channel cleaning brush, sometimes a pull-through one.
So let's talk about the main channels, suction and biopsy. You insert the brush down the suction valve at an angle so it actually comes out the other
All
end.
right, it has to navigate the bends to come out of the distal tip, and once it's out and you can see it, that's the critical inspection point.
And it's all down to the human eye.
Totally. The technician has to look at the bristles for any debris.
And this is the part that blew my mind. If you see anything, a speck, a tiny bit of tissue, you have to do the whole thing again.
The entire brushing process, yes.
So wait, let me get this straight. I'm the tech, I'm on my 8th pass, and I still see a little something on the brush. I have to go back and do it a 9th time, a 10th time.
You repeat until the brush comes out perfectly clean. The instructions are non-negotiable.
Wow.
That single speck you miss could become the seed for biofilm growth later on. This manual action, this repetition, is the only thing that physically gets it off.
That is just a staggering level of rigor. And you do this for the biopsy channel and the suction channel too. Everyone has to pass that visual test.
Every single one. So once that physical brushing is done, we move to flushing. Brushing scrapes it off, flushing washes it all away.
And this looks like a complicated plumbing job with all these flushing aids, tubing, adapters.
It's a connection maze. It's designed to force the detergent solution under pressure through every single internal channel.
Okay, so you attach aids to the suction connector and the biopsy port. And then you flush while intermittently covering the suction valve. Why do you have to cover it on and off?
That intermittent covering creates pressure changes, a sort of pulsing action. It guarantees the detergent isn't just flowing past the channel walls, it's being forced against them, scouring them.
So you're manipulating the fluid path.
Exactly, maximizing contact.
And for the other channels, like air and water, the setup gets even more intense, more adapters.
Yes, you're using multiple sets at once to create a closed system for all these different pathways.
And after all that connecting, the instructions say to flush with a fresh batch of detergent. Why fresh?
Because the detergent you just used is now full of the stuff you're trying to get rid of. It's contaminated. Using a fresh batch for the air and water channels ensures they get a truly clean solution. It's all about preventing resoiling.
And there's a special step for the side viewing scopes, isn't there?
There is. They have a little mechanism called an elevator dial. While you're flushing, you have to rotate that dial up and down over and over.
To get into that tiny crevice.
Exactly. That spot is notorious for trapping debris.
So once the whole detergent flush is done, you disconnect the tubing, but you leave the adapters in place.
You do. They act as protective covers for the next phase. Rinsing.
And this is another one of those critical transition points. You can't just rinse it in the same sink.
Absolutely not. That sink is now considered contaminated. The scope has to be moved to a separate clean sink just for rinsing.
Otherwise, you'd just be putting it back into dirty water.
You'd be recontaminating it after all that work. The separate sink eliminates that risk.
So the rinse cycle is just as intense. Rinse the outside, then flush all the internal channels with fresh water until everything debris, detergent, is gone.
You watch the water coming out the other end. It has to run perfectly clear. No foam, no specks.
And after the water flush,
Air? You immediately flush the channels with air to start the drying process. Moisture is the enemy here. Then you take off all the adapters and dry the outside with a lint-free cloth.
and now we get to the moment of truth, the final inspection.
Yes. This is done visually or often with a magnifying glass to be sure the cleaning was effective.
And you're looking for two things, right? Leftover gunk and damage to the scope itself.
Exactly. Any remaining debris, discoloration, anything like that means the cleaning failed. But you're also looking for cracks, corrosion, pitting, anything that means the scope itself is compromised.
And if you find anything,
It's pulled. It either gets recleaned or it's sent for repair. It cannot proceed to disinfection.
and some labs even do a chemical test, a cleaning verification test.
That's right. It's an objective check, a swab that tests for residual proteins or hemoglobin to prove it's clean enough for HLD. It adds that extra layer of confidence.
So once it's finally verified as clean, it goes into a clean bin for immediate transfer to a high-level disinfection room.
And that's the journey. Leak test, sink setup, exterior scrub, valve cleaning, that relentless channel brushing, the complex detergent flush, transferred to a clean sink for rinsing, air drying, and finally, inspection.
It's an incredible amount of detailed, human-dependent work.
It is the entire difference between a properly disinfected scope and a major patient infection risk.
And those key details really stick out now. Adding the detergent last to avoid bubbles.
Yeah.
Using the one correct single-use brush. And that absolute insistence on brushing again and again until it's visually perfect, that manual scrubbing is everything.
And it does make you wonder, doesn't it, as we close this out? If this foundational step is so complex, so dependent on the vigilance of the human eye and the perfect execution of these manual steps, what does that imply about ever fully automating this process for these incredibly complex instruments? Are we permanently dependent on a person doing these fragile steps perfectly every single time for patient safety?
That's a deeply unsettling but really important thought to mull over. The complexity of safety starts right there with a speck of debris you can barely see.
Oh,
Thank you for joining us for this deep dive.